Welcome to EDU World Space.
In this question, we are told that our cell potential, E naught, is a negative number. And then we're asked some questions about that. So in part A, we want to know if the sign of delta G, what's the sign of delta G for this reaction if E is negative? So refer back to the equation for delta G, or one of the equations for delta G, is that it equals negative NF E naught. So in this case, if E is a negative, that'll cancel that negative, and that will make delta G a positive value. On part B, they ask, will K be larger or smaller than 1? So we're looking for the K, the equilibrium constant. And in this case, I would look at the equation for delta G that involves K, where delta G equals negative RT natural log of K. And if we solve that for K, we can get delta G over negative RT is the natural log of K. And then to get rid of the natural log, we'll raise both sides to the e to the both sides. So then we get this just cancels, and this we get K on the right, but I'm going to flip it over to the left, equals e to the negative delta G over RT. So in this case, if E is negative, then delta G is positive. So then this is e to a negative exponent, and e to a negative exponent is going to be less than 1. On part C, we're asked, can the electrical cell, based on this reaction, accomplish work on its surroundings? So can we do work on the surroundings? And the answer to this is no. We cannot do work on the surroundings, because in order for work to be done on the surroundings, the reaction has to be spontaneous. And reactions, if you remember from thermodynamics, reactions with a positive delta G are non-spontaneous. And so this reaction does not occur on its own. And since it's not a spontaneous reaction, since delta G is positive and E is negative, you cannot do any work on the surroundings. Work on the surroundings requires a spontaneous reaction with a negative delta G.